Hello, my name is Jordan Huscroft. I am in the IWRM program and I'll be talking about plant factories. So plant factories, what they are, how will they benefit society, what you can grow, and how they will play an important role in the agricultural future of our world. So before we talk about that, I will talk about a growing problem. The problem is population growth. By 2050, we're expected to have over 9 billion people. 70% of these will be in urban populations, where 30% will be in agricultural or rural populations. To make up the difference of our population versus how much food we need, we are expected to increase our yields by 90%. So this can be challenging in a lot of ways. One way we're going to try to do this is by doing the plant factories. They will optimize our ability to grow different types of plants. So, what is a plant factory? It is defined as a plant production facility where a thermally insulated and nearly airtight warehouse-like structure is used to grow plants. So we will maintain light, temperature, nutrients, water, moisture, and CO2 to optimize our growing conditions. As we do more research into what a plant needs to be optimally grown, our efficiency will increase and we'll be able to increase our yields while lowering cost. So what about conventional farming? We'll always have conventional farming, greenhouses, and such. Factory farming is meant to supplement this and not replace it. We can't grow a lot of the crops that we can grow in a factory farm from outside, so we can't grow potatoes or corn, there's just not enough space for it. We're meant to be growing smaller plants. So growing conditions. So how do we actually grow these crops better than outdoors? So using LED lights, we can use lights that symbolize the light from the day, but because we don't have lights at night outside, we kind of lose our growing time. So by using other LED lights, we can grow plants throughout the night. By using hydroponics, we can maintain perfect control over our nutrients. And for water and CO2 and moisture in the air, we can control how much is available for the plants to uptake. Studies have shown that by increasing CO2 by 300 parts per million, we can increase yields by up to 50%. So using studies like these, we can increase our yields. What can be grown? So ideally, we want to use plants that are 30 centimeters or less tall. That just allows us to grow them in the different layers within our shelving. We want to use plants that are very quick growing, so lettuce and leafy greens, spinach, turnips, radishes, and even carrots can work. The reason we want to have these is because it takes sometimes just a few weeks to grow them, and then we can have quick turnaround, producing yields up to 20 times a year versus conventional 2 times. So some of the benefits: we have the power to grow crops anywhere in the world. 1% of the water used. It's completely organic, pesticide-free, and productivity is over 100 times conventional farming methods. So for example, growing lettuce on a conventional farm, you're using up a lot more land. The yield, or the ability to grow more crops per year, goes way down, and you use a lot of irrigation water. So criticism, the main one now is the cost. Is it productive to have one of these when you have to build a building or pay for electricity instead of using the sun? So right now in Japan in 2014, the cost or the production rates, 25% of the factories were successful in making a profit, 50% broke even, and 25% lost money. The major reason they lost money was due to poor management, and they just didn't have the system down perfectly. They weren't using CO2, for example. So the future of this, in Japan, they're designing a plant factory that will be operational in 2017 that is fully robotic, which will lower the cost of labor, which will essentially make it profitable. So in the future, we'll have plant factories in every city and urban setting, and possibly use it in space. And when we're colonizing new planets, we can use it for that as well. So the future is bright for plant factories, and these are my references. And I would like to thank everyone for listening, and Dr. Nagati, and TAs, and primary and secondary reviewers. And thank you for coming out. Any questions, please let me know.